We're at a grocery store. We're pushing 28 kilogram cart is being pushed, and it's initially rolling with a constant speed of 3 meters per second. We're going to go from the other side and push on the direction of it. So you're going to have a person right here pushing in the opposite direction of its motion. Okay? The grocery cart is going to be our object of interest. Alright, when you push on the opposite direction, the motion diagram is going to start at 3 meters per second. It's going to slow down. So you have your velocity is getting smaller, which means your change in velocity opposes the motion. Interacting with the cart is the floor, the earth, and the person that is pushing. So we're now going to draw a force diagram of the cart on the object. You have the force of the earth going down. You have the force of the ground pushing up. And you have the person pushing in the opposite direction of the motion. You can check your motion diagram with your force diagram because the unbalanced force should be in the same direction as the change in velocity arrow. Now in this diagram, we're going to put a coordinate axis. Coordinate axis is going to be positive y is going to be up, positive x is going to be to the right. Okay, so then we're going to set up Newton's second law. Alright, so in the y direction, if we look at the force of the ground and the force of the earth, we see that they're balanced. So the acceleration in the y direction is going to be 0. And that will equal, alright, the sum of the forces in the... Okay, so we know the net force here is equal to 0. And if we look at our force diagram, we have the force of the ground on the object minus the force of the earth on the object divided by the mass. And then in the x direction, if we look at this, all right, we have the force of the person on the cart divided by the mass of the cart is equal to the acceleration of the cart. Now, given what we're given, we know that the person pushes in the opposite direction at 12. So this is going to be a negative 12 newtons divided by the mass of the cart, which is 28 kilograms. And this would then give you the acceleration. If you solve for the acceleration, you get 0.43 meters per second All right, that's the acceleration of the cart. So now, assuming that the push of the cart, assuming you push the cart with a constant force for a while, how far will it travel in 2 seconds? So this goes back to our motion diagram. Initially, it was moving at 3 meters per second, and you're pushing it for 2 seconds, and you have an acceleration of... You have an acceleration of 0.43 meters per second. So now you can go back and use your motion equations to figure out how far the cart would travel in 3 seconds.